A warm welcome, I'm the Italian Dev and on my channel I upload weekly web dev tutorial videos. In today's video we are gonna code together a complete and fully functional Solana Web3 dashboard using Next.js and Moralis. At the end of this tutorial, if you code along with me, you'll have all the knowledge to authenticate Solana user with Phantom Wallet and all the knowledge to fetch Solana balance, SPL tokens and NFTs from Solana API provided by Moralis. If you like this type of content, please subscribe to the channel and hit the like button. It will help me a lot. Enough said, let's go straight into the code. My dear friends, we are now ready to code together this amazing Solana Web3 application using Next.js and Moralis. For this project I have already created the starter template. You can find it on my account under the Solana Next Moralis repository. I will leave this URL in the description down below, and this starter template is just a simple Next.js application with Tailwind CSS already configured, and I've created just two simple components. One is the screen that we will show to the non-authenticated user, and the other one is the dashboard screen. These components have no functionalities, so don't worry, we will code all the Web3 related code together. It's just to have a styled base foundation from which to start together without losing any time in writing any style related code. So once you are on this page, so you navigate to this URL, you have, if you click this code button, three options to download this repository file. One is to download the zip file, the other one is to open this repository using the Github desktop application if you have it installed, and the third option, that is the one I'm gonna use right now, to copy this URL, open a new terminal window, then navigate inside the folder in which you want to clone this repository. I'm already inside my desktop, and type the command git clone and paste. Oops, I don't know why I copied desktop, so let me copy back the URL, git clone, and paste the URL you have just copied. As you can see, the Solana Next Moralis folder is showing up on my desktop, so I can navigate inside this newly created folder and then open it with Visual Studio Code. The first thing we need to do once we open a new cloned project inside the Visual Studio Code is to open the integrated terminal and type the command npm install, so to install all the dependency needed. In this case, the starter dependency are set inside the package.json file. In this case, the dependency are Next, React, and React DOM, and then as dev dependency, as you can see, Tailwind CSS, and its dependency related, autoprefixer and postcss, and then we have the ESLint plugin installed too. So now, to do a brief walkthrough of this starter template code, we can always in the terminal type the command npm run dev, so to spin up a new Next.js server that will serve our application under the URL localhost 3000. So as of now, let me just split both the code screen and the browser so we can check both the code and visually what we have on the screen. So if we navigate inside the page folder and open the index.js file, since we don't have any logic to conditionally render or the out page for non-authenticated user or the dashboard, I'm just in comment or comment out what I want to show. So as of now, the auth component is commented, is wrapped in a line comment, and the dashboard is showing up on the screen. So our dashboard is just a simple page in which we show the Solana user wallet, so the one that the user used to authenticate to this Solana Web3 application. Then we have a card in which we show and grab from the Solana API provided by Moralis the Solana balance. As of now, this list right here, and also this one are just hard-coded values. Then I put inside this JSX element just for example purpose, but then we will dynamically fetch all this data. So, as I said, here we have the Solana balance. Then we have a list of SPL tokens. If you don't know the meaning of SPL, SPL is the acronym of Solana Program Library, and it's like as ERC20 is the protocol for the Ethereum blockchain, SPL is the same for the Solana blockchain, because Solana blockchain is non-EVM, so its runtime doesn't run on an Ethereum virtual machine, but this SPL protocol target the Solana parallel runtime that is called C-level, and it's a runtime written in Rust, and this, as I said, the runtime used by the Solana blockchain. So I will show you how to create from your terminal a brand new SPL token, but also how to take, if you don't have any SPL in your Phantom wallet, how to receive it from a nice faucet. And then we have also at the bottom, and here, sorry, before I move on, we have that is the token address, and here is the balance. And then here we have the token address of the NFTs, non-fungible token. So if we open again inside Visual Studio Code the components folder, as you can see, as I said to you before, I've just created two components. So if we navigate inside this dashboard one, we have just a div that represents our main container that takes the width of the screen, the height of the screen, and shows in a flex column direction this logout button that is justified self-end, and then we have this paragraph saying wallet address, then this hard-coded value, but we will dynamically fetch it, and then we have these three simple cards showed in a grid fashion. So as you can see, for mobile and then for desktop, they place in this disposition. And as I said, we have for the first one Solana balance, again this value we will fetch it dynamically, and then SPL tokens, these two also will be fetched dynamically, and it depends on the SPL tokens in the array that we will grab from the Solana API. These are the coded values, are these two one right here, and then we have the NFTs card. So this is the simple dashboard screen. Now, always inside Visual Studio Code, if we navigate back to the index.js, that is the only route we have. So this is properly a single page application. If we wrap this dashboard component with the line comment and uncomment the auth component, instead on the screen we will have this simple auth page with a background gradient color, so we can check it inside the auth.js components. Again, we have a main container that takes the width of the screen, the height of the screen, and displays in a flex column direction its children. And here we have the gradient from left to right, so background gradient to right, from this custom green to this custom purple. We have the H1 Sol dashboard, and then we have this button that takes inside this image component that is the Phantom logo right here, and then this text auth with Phantom. So as of now, all this JSX component does have no functionalities. And then just to finish this brief code walkthrough, I've created this underscore document.js, and this is a custom document file. So why did I create it? Because I wanted to apply this font JetBrains, and this is the font family, the custom font we load locally in our application, and I wanted to apply this Tailwind CSS utility class to the entire body tag. Then, as always, we have the underscore app.js file that is mandatory for every Next.js application. That is the file in which we wrap our entire application. So we put all the code in which the components that are intended to wrap our entire application. And in the public folder, as I said, I have inside an image folder the Phantom logo, inside the fonts folder the JetBrains monoregular WOFF2 font, downloaded from Google Font, and to make Tailwind CSS aware that we want to use this custom font loaded locally. First of all, I have customized the default theme that CSS provides us, defining the font family object with this JetBrains key in which we define this custom font we want to use, also a custom colors object with this custom color I've already set up. And if we navigate inside styles.css, where there is the globals.css file that is loaded inside underscore app.js, as you can see, we have at the top that 3 Tailwind directive needed, so add Tailwind rule base component utilities, and then at the layer base there is the font face rule, again in which we define the font family we want to use, and then as a source key we pass these URL parameters, and this URL is the relative path to this public fonts folder and then the name of the file. Now you don't prefix this one with the public, because Next.js already know that when static files needs to be fetched and to be used, Next.js already knows to go and check inside this public folder. So Next.js already know that this one points to the public folder, so we start /fonts, JetBrains mono -regular WOFF2 and format WOFF2, and so in this way we correctly load this custom font right here. So now that this brief walkthrough code we can call it to end, we can start to think to all the Web3 related code we need to write together, so to let's say transform this now just front-end Next.js application with any Web3 capabilities into a decentralized application in which we inject Web3 and in particular Solana thanks to an authentication with the Phantom wallet. So first of all, we need to, let me now exit from the split screen mode. So first of all, we need to navigate to Moralis.io. And Moralis is the development platform for all our Web3 stuff we are gonna use. I'm not gonna go deep and show you all the features that Moralis provides us, because really it's a huge ecosystem, Web3 ecosystem, and growing day by day. I have on my channel a playlist called Next.js with Moralis, in which there are some videos related to Web3 and Next.js project. In particular, there is a more than 2 hours long video in which we code together, again, a dashboard, but in that case related to the Ethereum blockchain. So we authenticated the user with MetaMask, we fetched the Ether's balance and all the ERC20 tokens held inside that MetaMask account that authenticated to that Web3 application. Then we fetched the last 5 transactions, we fetch also the NFTs, and also we allow user from the front end to send Ethers to other address. So if you check that video out, I will leave the description, the link in the description down below, and I think I will upload it also. I think it will show up right here as an info card. But for this project we are gonna only explore the Solana API that Moralis gives us. So, if you don't have an account, once you navigate to moralis.io, you can create one for free clicking this button. I already have an account, so I will click to login, populate this form with my credential and login. So now I am redirected to the Moralis dashboard, in which with a simple click, create a new server, we can spin up a complete Web3 infrastructure ready to be served in production and also to be scaled. Here we can call our instance as we want. I'm gonna call it Solana, let's say Next.js. Select region, choose the location nearest to your position. I'm gonna choose Frankfurt. Select network, testnet is okay, and for this one, for this purpose, the ring B Ethereum testnet is okay too. So then click add instance, and as you can see, as it happens for magic, we have a complete Web3 architecture set up with just few clicks. As I said to you, in this video we are gonna explore this Solana API provided, and as you can see here you have all the endpoints. We will make call to fetch the, as I said, the balance, so native balance Solana, tokens to fetch the SPL tokens, and NFT to get the NFT. So we will make a call to this account API related to the Solana API, then pass the network as parameter, and the address is the wallet address of the user that authenticate to our application thanks to Phantom Wallet. We are not gonna make hard coding this endpoint URL, but we will use some useful hooks provided by the 2 packages that we are gonna install right now to link our Next.js application to this Moralis server. So we can go back to Visual Studio Code, maximize this window, stop the running process in the terminal, and install the 2 packages we need to link to glue our Next.js frontend web application to Moralis. So we can make these 2 communicate, talk each other. The 2 packages are npm install Moralis and then React Moralis. Now let's wait for these 2 packages to be installed. It won't take much. So now that these 2 packages are installed, we can navigate inside. Let me close some folders so to reduce the volume of this tree, and we can open _app.js so we can wrap our entire Next.js application that lives all inside this next component, and we can wrap this next component with the Moralis provider component provided by the library React Moralis. So I can start typing Moralis provider. I have Alpha import plugin installed in Visual Studio Code, and as you can see, I'm importing Moralis provider from React Moralis. So we can move our entire application inside this component, and in this way we can consume this Moralis provider and the context that this Moralis provider provide us to be consumed in all the components we need. So right here inside this index component and so on. But this Moralis provider to work properly needs two props, because in this way it doesn't know to which server talk and send requests. So we need to tell this Moralis provider, hey listen, go reach this server and ask what you need, and they will give you back what you need. And to do this communication, we need to pass an app ID and the server URL. Now, we can store and handle these values thanks to environment variables, So at the root level of our project, we can create a new file, .env.local, and inside this file, we can define our two environment variables we need. But we need to tell Next.js to make Next.js aware that these two variables are safe to be exposed to the client. So how to do this? Just prefixing our environment variable name with the next public prefix. And then so we have two, I can just, copy and paste, and the first one is app ID and the second one is server URL. So we can start now to pass these two environment variables to the Moralis provider. They are empty, but they will be populated in just a few seconds. So app ID is equal to process.environment. And now a little bit of copy-paste work to avoid any typo. Next public app ID. And the last one, so the server URL is again equal to, I can copy all this process.env, but in this case I can copy-paste the next public server URL. Okay, so now we need to populate these variables, but where we are gonna grab these two configuration parameters related to our server? Well, we can go back to Moralis, select the server we have just created, and click the button View Details, and the model with all the server details we need will show up. There are a lot of configuration variables, but we need only the server URL and the application ID. So I can start copying the application ID and paste it right here, and then copy the server URL value and paste it right here. Nice. So now our Moralis provider is correctly set up and is correctly wrapping our entire Next.js application, that is just this next component. And what we can do now is to start to think to the authentication flow, and so how to authenticate Solana user with Phantom Wallet. What we can do is to, first of all, navigate inside the index.js, that is the only route we have for this single page application, and instead of line comment or not these two components, what we can do is to start to consume the Moralis provider thanks to the use Moralis hook, and grab all the methods and the Boolean values we need to perform all our Web3 related stuff and communicate with the Moralis Solana API. So we can start typing const curly braces, so it means we are gonna destructure some value from something, and here we have the use Moralis hook, correctly imported from React Moralis. So from the use Moralis hook we can destructure a Boolean value called is authenticated. So this is just a Boolean value, true or false, that will tell us, that will let us know if a user is authenticated or not. So, since we have now this value, we can just start typing a simple if statement saying if the user is not authenticated, do what? Just return the auth component, okay? So the user can authenticate. Else, if the user is not authenticated, return the dashboard component. Oops, I deleted some parentheses. So return the dashboard component. As you can see, this is a kind of implicit else, because since it's authenticated, it can only be true or false. So we can say if this is false, so the user is not authenticated, show to the user the auth page. Else, if the user authenticated, show the dashboard. So now, if we have code everything right, if we, again, in our terminal, spin up the server and check our web application on localhost port 3000, what do we expect? We expect to see the auth page, since we are not authenticated. So we can try to check emir localhost, and as you can see, the auth page is correctly showing up. So what we can do now, we can pass a method to this button, and so to give him the capabilities to authenticate Solana user thanks to Phantom Wallet. And again, in this case, the Moralis SDK and Moralis SOC will come in our help. So what we can do is to destructure from use Moralis the authenticate method. Now, we know that we need this authenticate method, we need to call this authenticate method where this button lives, and this button lives inside the auth screen. So we know that we need to pass the auth method to this component. So what we can do is to take this method and pass it as a prop to this auth component. So we can go now to the auth component and destructure the method we have just passed from the prop. So now we have a falle function, authenticate method, to be used inside this auth component. So what we can do now is to create a custom asynchronous and anonymous function that is able to call this authenticate method. So we can write const phantom auth is equal to async anonymous function, and inside here we can write a try catch block. We are not gonna handling error in a fancy way and in a proper way. So if we catch any error, we just console.log the error. Instead, if we are in the try block, so it means that things are running smoothly, what we can do, we can just call and await, because remember, this is asynchronous, await what? This authenticate method, and this authenticate method receives a parameter object. In this case, the mandatory parameter object are type, because we need to tell to this authenticate method that I want to authenticate user using the Phantom Wallet, because this authenticate method can be used to authenticate users with MetaMask, Elrond, Polkadot, and many other blockchain. But in this case, we want to authenticate user, Solana user, and so Phantom Wallet, so type sol. We can save, okay, and now that we have this custom phantom auth function that we run this authenticate method, we can navigate to our button, that this one is saying auth with phantom, and give pass to this button and then click JSX attribute, and right inside here call this phantom auth custom method. So now if we navigate back to our web browser. Let me minimize the window so that if everything works fine, the Phantom wallet pop-up will not take the entire screen. And if I open the developer tools and navigate to the application tab, I'm already right here, to local storage 3000, look what happened. So if I click Auth with Phantom, cool, a Phantom wallet pop-up will show up. Let me type my password in, unlock, and now we have a signature request saying Moralis authentication. We can also customize this message. I approve this signature request, and look, our web application is correctly showing us the dashboard screen. And look the magic happening right here. In the local storage, we have a new object called auth data, saved by Moralis from us under the hood, in which you have all the parameters that Moralis need to keep track of this session, this authenticated session, and also we have sole account, the sole address used to authenticate. Look, if you look at these 4 digits YOSR, and I open my Phantom wallet, look, YOSR, and look, now in my Phantom wallet I'm connected under the DevNet, because then we will fetch all this data from the DevNet network. So how to switch your network in Phantom wallet? Open this gear right here, this setting icon. At the end you have this change network tab, and here you select DevNet, because look, if I connect to the mainnet, my wallet is empty because this is just a development wallet, so no Solana inside right here. But since we are gonna call for development purpose, but because we can do also for the mainnet, but for the development purpose we will communicate to the Solana API, passing the network parameters as DevNet. Again, settings right here, change network, and select DevNet. That is api.devnet.solana.com, and inside here I have some DevNet Solana 1.9 and also 2 SPL token, but without a name, and I will show you how to grab them from a faucet or to create an SPL using the Solana CLI, command line tools, and also the NFT. But now let's focus again back on the auth flow. Don't give a look to this value because it's the same, because I just copy paste my address, but now this is hard-coded. Then we will fetch this value. And as I said, we have this auth data object saved right here inside the local storage, and it means I can refresh the page and I'm still authenticated. I can open this page into another tab and I'm still authenticated. So now that we know how to auth user and inject Web3 with Phantom wallet, so to authenticate Solana user, we can close this flow by logging out user. And again, we can move back to Visual Studio Code. We can grab from use Moralis hook another method, and simply is called logout. And as we did before, where we need to pass the authenticate method to this auth component, now we know that this logout button lives inside the dashboard screen. So it means that we need to pass this logout button as a prop to the dashboard component, so I can navigate inside component dashboard.js. Again, the structure from props this logout method, and what we can do. Here we have the button saying logout, and again we can pass a on-click JSX attribute and say simply logout. If we go back to our browser, look the magic that is gonna happen right now. Here you have all the auth data, but if I click logout, this auth object disappear from our local storage and we are correctly logged out from our Web3 application. So now, really, with a simple few lines of codes, we know how to handle a complete authentication with Phantom. So we know how to authenticate Solana user. Cool. Now, let me log in back again. So approve this, and we can start to tackle all this stuff we need to do, all this dynamic value we need to grab, let's say, in order. So the first thing we have right here is this wallet address. So what we can do is to navigate again, back to the dashboard component, find the paragraph tag in which the wallet address value needs to be passed, and delete this simple hard-coded value. So as of now, we are authenticated, but we don't know. Let's say we know because we sign the request, the transaction, but on the screen we don't have any info about the wallet address we use it to authenticate. So time to grab it again, back inside index.js, and it's time now to grab from useMoralis what? The user object. Where do we need to use this user object? Now we need inside the dashboard, so what we can do is to pass this object as a prop. So we can go back again inside the dashboard, not only the structure, the logout, but the structure, the user address too. And so what we can do now is we can define a new variable, call wallet address, and this is equal to what? The user object dot get method append to it, and which property do I want to get from the user? Let me see, just to visually show you the value we need. So select again the auth data. We need this value right here, sol address. So we can ask, we can append this get method to the user object and say go and get what? Sol address. Now let me just console log before to pass it to the paragraph tag. Open the console, clean, refresh, and look what we have right here. Cool, we have our wallet address correctly showing, but now we are not hard coding it. We are grabbing it thanks to Moralis. Look again, YOSR, and here YOSR. Okay, I'm under the DevNet, right. So what we can do now, not console log, but just take this wallet address and paste as a JavaScript value right here in this paragraph. So now, if I go back to the browser, look, we have this now not hard-coded value, but dynamic wallet address correctly fetched. So now, first things to do, done. Now we can focus on now to get the Solana balance. As you can see right now, we have this hard-coded 1.2356 Solana values, but if I open my Phantom wallet, under the DevNet, I have 1.99. So it's clear that we are not grabbing the correct value from the Phantom user wallet, but it's just hard-coded. Now, if you don't have any Solana under your DevNet, what you can do is to go to this website, spltokenfaucet.com. I will leave the link in the description. Click on Select Wallet, click Phantom, then click Connect. It will ask to sign the transaction and authenticate. So now here we have the address to airdrop. Under network selection, be sure to select DevNet, and this will airdrop what? Sol so it will give us one Sol DevNet, and then we'll give also a dummy SPL tokens, and this is a dummy airdrop, so you will have also this SPL token that will allow you then, if you don't have, again, as you don't have any SPL, any DevNet Solana, you may not have any SPL tokens. From here, you can grab this dummy SPL token too, and so then when we will fetch the SPL tokens inside the Phantom wallet, you will see it showing up right here. Let's put, to make something different, 150. So again, get one Sol, airdrop requested, airdrop successful, get dummy. We need to approve this transaction that needs some DevNet Solana to be paid. Dummy airdrop successful. So if I open now my Sol account, as you can see now I have 2.99 Solana, and now it's saying here that I have also 2,500 dummy, that is one of these two, or this one or this one. Look, it's this one right here, 2,500. Look now, success, and then we will show this value, and this values too is an SPL I have created from the Solana CLI right in here in this list. So now that you have both Sol under the DevNet and also SPL under the DevNet, we can start to fetch this value and this value. So let's start from the Solana balance. So the first thing we can do is to find this paragraph. We can leave this span saying Sol, because we know here we will show Sol, and delete this value. So now we don't have any hard-coded value. So now we need to find a way to grab, to fetch this Solana balance. So now we can start to use what? The Solana API. So I can say let Solana API is equal to, again, use Moralis Solana API hook will help us to communicate with the Solana API. So as I showed you in the Moralis dashboard, thanks to that use Moralis Solana API, we can make call with custom methods to all of these endpoints. But we will do it without fetching and passing headers and parameters. We will do it with this use Moralis Solana API, and so to append some method to this Solana API and also pass parameters and everything we need. Now, we need to show this value after the component is mounted. So we can call all the fetch function we need inside the use effect. So let's start by creating a use effect without import, callback function into it, and then empty array list. Now, since all this method that we are gonna use, and just to be clear, we will need a method to fetch Solana balance, a method to fetch SPL tokens, and a method to fetch NFTs. All these methods are asynchronous, so we cannot type async here and then await inside the use effect, because this is really bad coding. Never do something like this, because you will put yourself in the condition to not yourself, you put your web application in a condition in which you can see some race condition happening, because use effect is a callback. A callback for nature is synchronous. So you cannot define it as asynchronous, because if you define it as asynchronous, this use effect at every re-render is not able to return at the end of the callback a cleanup function, so you will have race condition, memory leakage. So never put async here and await here in this way. But what you can do is to define an asynchronous function right inside the use effect. You can also define it outside, but if you define it outside, then you need to pass it in the dependency list, so to not run the use effect at any re-render. But in this case, we will define this asynchronous function right inside the use effect, and we will manually call it inside the use effect. So, and we will put all these three methods inside one giant function that will, asynchronous function, that will contain three try catch blocks. So let's call it const fetch data is equal to async and our anonymous function. So now then we can call this asynchronous function fetch data. So now we have everything to do to let our web application to go communicate with the Solana API, fetch the data, and show once the component is mounted down below in our dashboard. So inside our fetch data, let's start with the first try catch block. For the error, as always, console.log what the error, and inside this try, now let's grab let result be equal to await what Solana API dot account dot what go and grab the balance. Now we need to pass two parameters to this balance. Balance is referred again to the native balance. So the native balance for the Solana blockchain is Solana. Which parameters we need to pass? Remember, back Moralis Dashboard, Solana API, we need to pass the network parameter and the address parameter. So as network, I said to you, we are in the DevNet, under the DevNet network. As address, we need to tell from which account we need to grab the Solana balance. And this is the wallet address we have right here, and this is the address we use it to authenticate. So now, if everything works fine, for now, so if this try works smoothly, just console, not confirm, console.log what result. Let's see what happened now. So we have our user, we defined before the Solana API from the use Moralis Solana API. Inside our use effect, we define a custom asynchronous function. Inside here, we have the first try catch block, and the first one is used to get the balance. And then we call this fetch data. So if everything works fine inside our console, developer tools, something should happen. Let me clear and refresh the page. So now in the use effect, the fetch data is running, and look what we have. We have an object with the Lamport's value and the Solana value. Let's focus before on this Solana. It's saying 2.990. Let me open my wallet and look. 29909 is correctly fetching Solana. Now, what this Lamports is? Lamports is just another fractional native token to handle micropayments, and it's 10 at the power of -9 Sol. The name Lamports was chosen by Yakovenko, the ideator of Solana, because he found inspiration to code this proof of history algorithm that is at the base of the Solana runtime from the Laszlo Lamport, that was a mathematician who gave amazing contribution in studies of distributed system. So, as of now, we are not grabbing these Lamports, but you know that with this method, you not only get the Solana value, but you also get the Solana value expressed in Lamports. As you can see, it's 9 decimals. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is the value right here. And this is, as I said, used to handle micropayments. It's like the way in Ethereum. It's not at the power of minus 18, I think, the way, but it's minus 9 for Solana. So now that we have this value, we can just show this one right inside here. So instead of console logging the Solana balance in the console, we can save it in a state. So up of the top we can say let Solana balance and then set Solana balance equal to use state, and as of now it's an empty string because let's check, yeah, the value are coming back in a form of a string, and I'm just saving this Solana value. That's why as a default I'm passing an empty string and not an object of empty string. So now instead of console logging this result, what we can do is to set Solana balance equal to result.solana. Cool. So now we can grab this Solana balance, go to the paragraph in which we need to show the Solana balance and paste this JavaScript value. Now this number will be long, right here, look, but we can grab, let's say, till right here or right here. So let's do a slice from 0 to the start, from 6, because there is the point at the starting one call, so we have 4 digits after so. So we are now correctly fetching the Solana balance right inside this account. And as you can see, the numbers are perfectly the same. So now it's time to fetch this Solana Program Library tokens. And as you received from this faucet before, your SPL tokens now, if we code it right, will be shown inside this card. As of now in my wallet there are 2 SPL tokens and 1 NFT. So we can go back to Visual Studio Code and again exploit a method coming from this Solana API. So what we can do, we can again open a new try catch block, console.log the error as always. In the try catch now again we have a let result equal to await what Solana API dot again account dot what get SPL. Look, we have this method, we pass as we did before the 2 parameter, so the network parameter devnet and the address parameter that is our wallet address. So now we can, just to test, console.log the result we got back if the try ran smoothly from the Solana API provided by Moralis. So we can now move back to our web application, and as you can see, don't take a look at this token right here. Let's start deleting this hard-coded value. So this 2, we will grab it from the length of the array, and this li will come from, again, the array we got back. So let me clean and refresh to have the console clear. And as you can see, now the use effect runs and we got back this array containing 2 objects, and one is this token right here with this mint address. This is the address of this token. This is the associated token address, the one because you need to create an associated account to mint this token, and this is the same right here, but this one is amount 1000, this is the amount 2500, so it means that probably this is the dummy token coming from the faucet I showed you before, And just to check, if I open my Phantom wallet, as you can see right here, we have this one, GH9Z 2500, GH9Z 2500, and then we have this ATHD. So if I go back, this one, AHD 1000. So now we fetch correctly the data. So what we need to do now is to show a number right here that corresponds to the length of this array. So it means the number of SPL tokens we have. Then we need to show the mint address, that is the address of the token, and the amount in a list. So what we can do is, instead of console logging this result, we can create a new state. Let SPL balance and set SPL balance is equal to use state. Now the default state is an array of empty object as of now, so we can grab this setter, and instead of console logging the result in the second try catch block in which we fetch the SPL, we pass the result. So now we have the result saved in our state, so we can go down to the SPL token, and inside the unordered list, what we can do, we can say, take the SPL balance if the length is greater than 0, so it means that we have some SPL token saved, so as sense to show the list item, the unordered list item. What you can do is to SPL balance dot, sorry, I missed the conditional, so and SPL balance dot map, and take the SPL element, take the index, and return what the li element. First of all, let's pass the unique key, that in this case is the index we are grabbing from the map function, and inside right here show what the SPL.mint that we have. And look what happened. We have the mint address right here. Now it's really long, so the first one is AHTD and the second one GH9. So what we can do, first of all, we can slice it a bit, starting from 0, let's give 12 as an ending value, and then pass some dots at the end, so it means that we'll have more values. Cool. And then what we can pass is to give a bit of space, so an empty space, and then take from the SPL what the amount, and save. And look, 1000, 2500, and then the last thing we need to do is to pass the length of this array that will last the number of SPL tokens inside our wallet, and we can easily do it inside right here, and this to SPL.length. No, not sorry, SPL balance, because we are not inside the map. Reading slice mint, okay, because at the end and at the beginning it cannot read because we need to wait for the component to be correctly mounted. So let's solve this now in this way. And look, we have these two correctly showing up here. Then we will solve also this flashing rendering, because it's still waiting to grab all the values. So we will render this only while the component is mounted. And now it's time for the NFT. Maybe you don't have an NFT inside your wallet under the DevNet. So what you can do is to go to spl.solana.com, and here is the program library. You can follow all the instructions to install the Solana CLI, and from here you can grab all this command to first of all, create your own fungible token, so a simple SPL token with the command SPL token create token. It will create this token that is the mint address with this signature. Then you need to pass some supply, but to pass a supply you need to create an associated account that was that address saying associated token account right here. And you can really, it's really easy. I will show you just how to create an NFT. Let me go down here, create a non-fungible token. So what I can do, and I have my Phantom wallet connected to my terminal, is to run the command. So SPL dash token create token with the flag decimals 0, so with 0 decimals. Now it's creating an NFT token, and here is the token address. Now again we need to create an account associated to this token, so let me copy this address before I move on, and we can now write SPL token create account and pass the token, so to which associate the account. This is the address of the account associated to this token. Now we need to mint this token into the account associated to it. So what we can do is to SPL again token mint, then pass the address of the token that is the one right here. Oops. And let me copy, paste. Then we need to pass the value 1 where, and again in the associated account that we have just created. So this value right here, we can copy now, paste. Now it's minting the token inside the account. And then here you can disable future minting, but we can avoid, we can skip this step right now. And if I open my Phantom wallet, instead of having just an NFT, I have now, I don't remember the token address is, let me check, GHFN9C. GHFN9C, so it's this one. Look, we have one NFT, we just minted into this account, and we can check it on SolScan. Look, 1 minute ago, we minted this NFT inside our Phantom wallet under the DevNet server. So now we can retrieve this NFT right inside this web application, so inside this card right here. So we can start by deleting this hard-coded value. So let's go back in Visual Studio Code, remove these NFTs ones and this LI inside the UL, and it's like to do what we have just done for the SPL again. A new try catch block, and let result in this case is equal to await what, again Solana API dot account dot get NFTs, pass the parameters that are network again, and this devnet, and the address, it's again wallet address, then just console.log the result, the error, sorry. And as of now, let's just console.log result. Okay, so if we move back to our application, look, now we have again an array of 2 objects, and in this case we have just mint So this is the address of the NFT, and this is the associated token address, the one I showed you with the command right here, where is SPL, SPL token create account, and pass the address of the NFT you just created with this command. This will create this associated account, and then you mint this token address one in this associated account address. So it's just the one right here. This is the associated account, and this is the token address. And again, you have just one as value, so it's not reported right here. Again, mint and associated token. So it means that in this Phantom wallet, I have just two NFTs, and it's right as I showed you before. So what we can do now is again to create a new state in this case. So let NFTs balance and set NFTs balance, and this is equal again to a news state, and it's again an array of empty object right now. So instead of console logging the result, we can call the set NFTs balance and pass the result. So now we can go back to our NFTs, and again inside the unordered list, what we can say? We can say if NFTs balance dot length is greater than 0, so it means we have NFTs, and NFT.balance map, we are gonna map inside this array. We will grab what? The NFT and the index, and we will return what? The list item element of the unordered list, again as key the index, and here as address we can pass what? The NFT.mint. Now we can go back and look, we have these two address correctly working, but now the mobile is not working correctly because it doesn't resize, so we can exploit, let me check a bit, some utility classes from Tailwind CSS. Open Tailwind CSS, get started, quick check. Let's start by something that is related with truncate. So this, no, maybe, yeah, we can fold this text ellipsis, so it will not only truncate, but also overflowing text with ... So we can just copy this utility class, text ellipsis overflow hidden, go here and pass a class name and paste text ellipsis overflow hidden. So let's see if the mobile is still working fine. If I resize, look, the address is resizing, and now I don't have any overflow. Cool, so now we just need to pass the number of NFTs we have, and we can easily do it right here. Near to NFTs label, we can say NFTs balance dot length. Save, and look what happens. Now we have these two. Cool. So our Solana dashboard is mostly done, and the last thing we can do to finish this tutorial is just to fix this delay in rendering, because as you can see, as soon as the component mounts, something will show up inside the cards, and then this card will upload the render with the right values. So we can easily solve this by creating a new React state. Let's call it isLoading. So let isLoading and set isLoading. And this is equal to use state at the beginning is true, because as you know, we call all our method inside this useEffect. So as soon as the application starts to render, all this data are being fetched asynchronously inside our use effect. So it means that it's fetching, so it's loading. What we can do is that at the end of this, all of these three try-catch blocks, we can set the new state and say is loading is equal to false. So it means now we are able to keep track when this data start to being fetched and so is in a loading state and as default is true, and when all these try-catch blocks end and all our data is fetched, we set this loading state as false. So now, as for the first example, we have not this one, but right here, inside the Solana balance, we have this paragraph, this one, just to be visually clear, and as you can see, as soon dApp renders before the sol appears, and then it re-renders with the right amount of Solana we have in our account. And what we can do to avoid this flash state right now is to conditionally render this paragraph and say if it's not loading, so it means the loading state is false and we are at the end of all this try-catch fetching data, we can say if it's not loading, so return and so render this paragraph tag right here that is composed by the Solana balance and then this span with the Solana symbol. So look what happened if I refresh now the page. The sol in the card is not showing anymore and it will show only when we are correctly fetched this number, this data. So we can do the same now for this number 2 right here and also for the SPL token address and amount, and the same for these two related to the number of NFTs and this mint address of the NFTs. And because remember, these are all data that we are dynamically fetching from the Solana API. So again, with our isFetching state, look here, we have this SPL balance.length. Now we can say with the ternary condition, if it's not loading, show the length of this array, else show a simple empty string. It means we still don't know how long this array is because it's still being fetched inside the use effect, and only once you have it and so this state is changing to false, then show it on the screen. And so we can do the same. Before we execute the map over the SPL balance, okay, we can check if we are not loading anymore. So we can say we can add another end statement, say end is not loading. So if the length is greater than 0 and we are not loading, so we mean we loaded correctly all the data, go and map over this array. So we can do the same for the NFT balance because we are perfectly in the same situation. So if it's not loading, show the length of this array, else return an empty string. And again here we can add a new condition and say not only if the length is greater than 0, but also if it is not loading. So we can now check our application and we expect to see this card with just Solana balance, SPL tokens and NFTs being rendered, and then all this card being populated by this dynamic data only once the data are completely fetched. Look what happened. I'm refreshing the page. now the card, as I said you, with only this non-dynamic value, and then it populates with all the dynamic values. So now we can finish successfully this tutorial. I was really happy to bring you this my little knowledge about how to communicate to a Moralis server and exploit the Solana API that Moralis provides to us and render it in a Next.js web application. If you think this kind of video can be useful to you and you also enjoyed coding along with me this Solana Web3 dashboard, please really hit the like button, subscribe to the channel and comment in the section down below. Thank you very much for watching. The Italian Dev. Bye bye.